Welcome to the FMSP online revision. This session is for AQA M1 and the question is on kinematics in 2 dimensions, and it's question 7 from June 2010. So let's have a look at the question first of all. It says a particle of mass 10 kilogram moves on a smooth horizontal surface, so there's no friction. A single horizontal force 9I plus 12J newtons acts on the particle, where I and J are directed east and north respectively. So in part A we're asked to find the acceleration of the particle, and then in part B it says at time t seconds the velocity of the particle is v meters per second. When t equals 0, the velocity of the particle is 2.2 I plus j. So that basically is telling us our initial velocity here, isn't it? And it's also telling us that it starts at the origin. So we've got three things to do. Firstly, we've got to find the distance between the particle and the origin when t equals 5. We've got to express v in terms of t, and we've got lastly to find t when the particle is travelling northeast. So let's consider first of all what's happening here. So we've got a particle. It is moving. It's on using from a horizontal force 9I plus 12J. So just be very sort of careful about this. It's on a horizontal surface. The force is moving it along that horizontal surface. So the only force, and it is a smooth surface, so the only force that is actually acting on it that will create this acceleration is 9I plus 12J. So we're going to use F equals ma, Newton's second law, where the force then is 9I plus 12J. The mass, we're told, is 10 kilograms, and we're asked to find the acceleration. So all of these are vector quantities, so just being careful about that, and that means that the acceleration dividing through by 10 will be 0.9I plus 2J. And that, of course, will be newtons, the unit of force. So that is our acceleration. If we now look at the next part, it says at time t seconds the velocity is v, and when t equals 0, the velocity of the particle is 2.2 I plus j. So we've already mentioned that means that u, the initial velocity, is 2.2 I plus j. We also know from what we've just done in part A that the acceleration is 0.9 I plus 1.2j, and we're asked to find the distance between the particle and the origin when t equals 5. So we're using the fact that if we have the general position vector for time t will be ut plus a half at squared. It'll be given by that. So this is the equation that we need. We of course want to find it when t is equal to 5. So we're effectively finding r of 5. So r of 5 ut, so 2.2 I plus j times t plus a half a, which was 0.9 I plus 1.2j, and then we're multiplying that by t squared, which is 5 squared. Now if we do that carefully, and I haven't put a 5 in there, so I'll also just get that and make that a 5 for some reason or other. I haven't done that. So if we put the 5 in there, Then 2.2i times 5, that's going to be 11i plus 5j. So all I'm doing now is multiplying through. 25 times 0.9 times a half is actually 11.25. So we have 11.25i, and a half times 1.2 times 25 is actually 15. So with 15j there. And it's now just a matter of bringing the I components together. We have 22.25i plus 5 and 15, 20j. So we now have our position vector when t is equal to 5. So just bear in mind we were asked to find the distance from the origin. So we've gone 22.25 in a horizontal direction, followed by 20 in a vertical direction, so it is just a matter of Pythagoras' theorem now. So we just want to find that. So Pythagoras' theorem will tell us that s, the distance, is the square root of 22.25 squared plus 20 squared. And if you check that carefully and round the answer to 3 significant figures, then you should get 29.9 meters. So always try and remember to give your answer to 3 significant figures and put in your units. So now we have got the distance. So part 2 asks us to express v, that's the velocity after t seconds, in terms of t. So if you remember, we already know that u, the initial velocity, was 2.2i plus j. We also had the acceleration vector, which was 0.9i, we worked that out right at the beginning, plus 1.2j. So the velocity vector v after t seconds, we're using v equals u plus at, so it will be 2.2i plus j times, that's u, plus at 0.9i plus 1.2j times t. So we're just expressing it in terms of t. So what we could do here, so that is now an expression, so that's all we need. You could at this stage bring your I components together if you wanted to. It's not essential, but we certainly could do that, and do that as 2.2 plus 0.9 t I plus 1 plus 1.2 t in the j direction. Now either of those answers will be sufficient for part 2, but we do need this answer when we come on to the third part, because the important thing about the third part is that you're travelling northeast. So if you're travelling northeast, like that, northeast, then think about what that is. It means the angle is 45 degrees with the horizontal. It's also 45 degrees with the vertical, which means your I components and your j components must be equal. So I and j components must be equal, and that's the important part about this last bit of the question. And so that means that what we can do now, we've got the I components here and the j components there, so that means that 2.2 plus 0.9 t, that's the I component, must be equal to 1 plus 1.2 t, that's the j component. That's the only way it can be travelling northeast. So just simplifying that, we'll have 1.2 then we'll take the 0.9 across, and that gives us 0.3 t. Dividing through, we get t equals 4. So at 4 seconds, the particle is travelling northeast. And we've finished. So let's just go back and look at how marks were awarded for this particular question. So just 2 marks for the first question, a method mark for using Newton's second law, and an accuracy mark for using it correctly. So just 2 marks there. When you come to part B, the first part, to find the distance between the particle, then you're getting a method mark and an accuracy mark here. There's a method mark and an accuracy mark for getting your position vector. You're then getting another method mark here using Pythagoras theorem, but that is dependent on you having got the method mark earlier. So that's important that you got that. And then there's an accuracy mark for getting 29.9 meters. So 4 marks for that bit. And then if you look at part 2 of part B, then you get a method mark for using V equals U plus AT with the U correct values of U and A, and an accuracy mark if you've got it all correct. So 2 marks for that. And then in part 3 there's a method mark for seeing that you can put it in this form. So actually that form there is important for part 3, and there was a method mark for doing that. And then you had an accuracy mark for equating the I and J components, and another accuracy mark for ending up with an answer of 4 seconds. So 11 marks in total for that question. So don't forget, if you want to access more revision videos, then you can go to the FMSP website and follow the link to online revision.